Hi. You're at station 5 and or 6. Both of those stations are about ions, so we're going to do a little bit of recap of what that is and what that means before you start. First of all, this slide says atoms are neutral, and they are neutral when they have the same number of protons as they do electrons. The positive protons cancel out the negative electrons. For example, carbon, 6 protons, 6 electrons, cancel out, neutral charge. Same thing with all of the elements on the periodic table. Here's an example of sodium and chlorine. These are showing their electron structures. The first shell holds 2, the next one 8, and the next one 8 for our purposes. The valence electrons are the only ones that matter for bonding and reactivity with other elements, so we are going to use the Lewis dot structure that shows just the valence electrons. Sodium has 1 valence electron in its outer shell right here, so we put 1 dot. Chlorine has 7, so we put 7 dots. This shows the dot structures of a whole bunch of different elements. All the ones in group 1 have 1 valence electron, in group 2, 2 valence electrons, etc., all the way across. All elements are trying to get the electron structure, at least the electron dot structure, the valence shell of the noble gases. The noble gases are stable and unreactive because they have full valence shells. Whichever one is their outer shell, it's full. We usually call this the octet rule. Here it is, you can see 8 valence electrons in neon and the rest of the noble gases below. Helium is the exception to that rule. Its only shell is its very first shell, the one that holds 2, so it does have a full valence shell even though it only has 2 electrons. All of the other elements on this table are going to try to become like the noble gases, and that means either gaining or losing electrons to fill their shells. All of these ones have 7, so they want to get 1 more. They're going to gain an electron to become like the noble gas that's next to them. Oxygen will need to gain 2, etc. If we look at the other end of the table, over here at our metals, sodium, potassium, there's calcium. These are going to need to lose their electrons to get to be like the noble gases. When sodium, loses this one right here, it becomes like this. It has the 8 valence electrons of neon. They're all going to try to do that. Some have to gain and some have to lose. Here's the key to charges. Ions start as neutral, but then they lose electrons. They become positively charged. We call them cations. And anions are the opposite, negatively charged because they gained electrons. At this station, we're going to talk about cations. Cations are positively charged because they have lost electrons. Remember that because cats are positive and cute and furry and positively charged. The sodium atom here is going to be neutral, equal electrons and protons. So right now, the sodium has 11 protons. That's what sodium always has, so it also has 11 protons here. The sodium atom, when it's neutral, also is going to have 11 electrons. That adds up to 0 charge neutral. But what happens here is that this sodium is going to lose this valence electron. When it does that, its charge is going to change. It still has 11 protons, 11 pluses, but now it's only going to have 10 electrons. When it only has 10 electrons, it now has a -1 charge. A positive 1 charge, because there's more protons than there are electrons. The purpose of that is for sodium to get a full outer shell. When this electron goes away, that orbital is no longer full, so our outer shell is now going to have our 8 electrons. That's all that there is to cations, is losing electrons to get a full outer shell. Good luck with your work at this station.